right, so section 7.4. Now we're going to actually find and do a full-out problem involving confidence intervals for proportion. Very similar to section 7.3, so we're just going to put it all together. One video for section 7.4. So how about that? But it's a longer problem, so be ready. Okay, so again, we're going to use what's called this four-step process in this problem to construct and interpret a confidence interval for a population proportion. So again, it's a four-step process. This is how we build our confidence intervals. It'll be very similar to how we do the means in section 7.6. So again, how 7.3 and 7.4 behave, 7.5 and 7.6 behave the same way, except it is with means. All right, so first, you're going to state the parameter you want to estimate and the confidence level. This is very much like we talked about in section 7.1. Identify what you're trying to estimate. And again, make sure you state the confidence level. Okay. Number 2, you're going to identify the appropriate inference method, and you're going to check the conditions. So the inference method is right here. It's a one sample z interval for p. We are using one sample value. We use the z, we find our z star, right, our critical value. It's an interval, and we're doing it for a population proportion p. Now, when you check your conditions, from last section, you learned that there are 2 conditions to check. The first one is the random condition, and the second one is the large count condition. So make sure you check those conditions. Third, we're actually going to find the confidence interval if the conditions are met. Remember, here is your confidence interval. Your point estimate is your p hat, your sample proportion, plus or minus, and now here comes your margin of error. Z star times the square root of p hat times 1 minus p hat all over n, and again, that whole thing is in a square root. This is your margin of error, and you're going to add and subtract that margin of error to the sample proportion to get your confidence interval values. And then last but not least, you're going to conclude, and that's where you're just going to interpret your interval. That is from section 7.1. So if you need a refresher on that, you can find that there. Okay, and there it is in a nutshell. All right, so let's take a look at our only example. Example 1, got sleep. Sleep Awareness Week begins in the spring with the release of the National Sleep Foundation's annual poll of U.S. sleep habits and ends with the beginning of daylight saving time, when most people lose an hour of sleep. In the Foundation's random sample of 1,029 U.S. adults, 48% reported that they often or always got enough sleep during the last 7 nights. Calculate and interpret a 95% confidence interval for the proportion of all U.S. adults who would report they often or always got enough sleep during the last 7 nights. So this would be very interesting to do right now in today's current climate with COVID. I know that it's kind of interrupted a lot of people's lives. I will say that I don't tend to stay asleep as long as I used to. I don't know. They say as you get older, you need less sleep. But I feel bad for you guys because you need your sleep. And I know a lot of you do not get your sleep. So do a better job. Your body will thank you. Okay? So again, the sleep study, this last sentence is very important. It sets up what we're trying to find. So it helps us get our statement to state our what we're doing. So we want, this is how your state's going to go. We want to estimate, and this is where I identify the parameter. P equals the true proportion of all, and now we're measuring from U.S. adults. And again, I'm right here, the true proportion of all U.S. adults who would report they often or always got enough sleep during the last 7 nights. I'm just going to restate that. Adults who would report they often or always got, that's my quotations, it's terrible, got enough sleep during the last 7 nights. But then you have to also state the confidence level. So I'm going to say at a 95% confidence level. At a, and again, it comes from right here, at a 95% confidence level. And there we go. And that's your state. Okay, so that's what you do. Okay, next is the plan. All right, so here is my plan. First off, I'm going to write down what the inference method is going to be. So we're looking at one sample. We're building a z interval, and it's to estimate for p. One sample z interval for p. And now we check our two conditions. First is the random condition. And again, right here, random sample of 1,029 US adults. Just going to write that down. Random sample of 1,029 US adults. Again, I think it's important to write down the number and who they are because you want to state that it's a random sample from your population. So that's what we did. Okay. And now we must do the large counts condition. So over here, I'm going to go ahead and write down my two important values. My first important value is the n value, and that is the sample size. And we just wrote it down, 1,029. And then next is your p hat value. Remember, we're estimating for p, so you don't know the p value, but we do know the p hat value. And it was right there. P hat is this 48%. So your p hat value is 0.48. And now we need to check if n times p hat and n times 1 minus p hat are at least 10. So n, 1,029, times p hat. And if I do that in a calculator, so 129 times 0.48, I get about 493.9. You could round that up to 494 if you wanted to. 493.9. You could write down 0.92 if you want to. I don't care. But that is at least 10. And then we do 129 times 1 minus 4, or 0.48. And when you do that, you get 535.08. So I'd say 535.1. You could 535.1. You could also just say 535 if you wanted to. Doesn't matter. But that's at least 10. So good. So our conditions are met. So we are good to go and do the calculations. So I'm going to erase this and we'll do the calculations next. All right, so here we go. Let's do them now. All right, so when we do the calculations again, we need to build this interval p hat plus or minus z star times p hat times 1 minus p hat all over n. I don't know why. I was focused on those hats and they look like n's to me, so I'm going to make them better. Sorry about that. So this is p hat, this is p hat, and this is n. And again, that's all inside a square root. So from the step 2, the plan, I know that n is 1,029. I know that p hat is 0.48 or 0.48, but now I need to find z star. And in order to find z star, I need to look at my left tail area. And I get that from the confidence level. That is the middle 95%. So we're going to take 1 minus 0.95 to find the area of the tails and then divide by 2 because I only need the left tail. That's 0.05 divided by 2, which is 0.025. This is the value that I'm going to type into my probability stats applet. So let's go there. Come here, stats applet. Stats applet, probability. Yes, it's normal because it passed the conditions. We are calculating a value corresponding to a left tail area, our mean, and standard deviation is always 1. And now I'm going to calculate or type in that left tail area. That's 0.025. And there is my z value. So we're going to make that positive, and that's our z star value. So I'm going to go ahead and finish on this slide here. So we have, again, n was 1,029, p hat was 0.48, and now our z star is 1.96. So to build my confidence interval, we'll start with 0.48, the point estimate, plus or minus 1.96 times the square root of 0.48 times 1 minus 0.48. All over 1,029 in that square root. And again, if you remember, what I told you guys to do was just bring down the 0.48, bring down the plus or minus, and let's go ahead and type in this margin of error and get that estimated to 2 or 3 decimals. always go to at least the decimal length of the point estimate, if not one additional. Okay, so let me take a picture of that real fast, and then we'll go ahead and type that into Desmos graphing calculator. Okay, all right, so I got it taken. So let's go to the graphing calculator here, and we're going to go ahead and type in 1.96 square root fraction. Okay, and it was 0.48 times 1 minus 0.48 all over 1,029. And again, if I'm looking at this, I'm going to round. You could probably round to 2 decimals if you wanted to, but I'm going to go to 3 just because I like to go one more than, I typically like my proportions to be to 3. So this 5 makes the 0 become a 1. So my margin of error is going to be 0.031. So our point estimate is 0.48, and we're going to add or subtract 0.031 to get our values in our interval. All right, so I'll come down here. Okay, and I'm going to do 0.48 minus 0.031 and 0.48 plus 0.031. And there's my values that make my interval. So my interval for my population proportion is going to be between 0.449 to 0.511. Again, about 45% to about 51%. Okay, so that's the end of the do. And now we're going to go back to the slideshow and do the conclusion. 0.449 to 0.551. Okay, and now back here, let's go ahead and conclude what we need to conclude, and then we're done with our day. Right? So conclude. So now we go back to section 7.1 and we say we are 95% confident that the interval from 0.449 to 0.511 captures the, and now we just restate what we stated, captures the true proportion of all U.S. adults who would report. They often or always got enough sleep during the last 7 nights. And there we go. And that's how we're doing our problem. So again, you'll see it's nothing new. It's just building everything together. Okay. All right. So again, very much related to section 7.3. Should be, again, nothing new. It's just putting that 4-step process together. All right. So best of luck on the homework, and let me know if you have any questions.